viewers, welcome back to free engineering tutorials on operating system. In previous video, we had discussed about different types of operating system. In this video, we will talk about what operating system can do. So, firstly, we will talk about modern operating systems are interrupt driven. What are interrupts? These are special signals provided by or signaled by input-output devices or different devices to gain the attention of operating system. If there are no processes to execute, no input-output devices due to service, and no users to respond, OS will sit quietly. Events are almost always signaled by occurrence of interrupt or trap. So what are traps? So these are special programs which are signaled because of an error happening at the time of execution of process. So it is a software generated interrupt caused either by error or a specific request from a user program that an OS service be performance. Each type of interrupt separate segment of code in OS determine what action to be taken. So it signifies that OS has to take some action to get out or make out from trap. Now at the very least we need two separate modes of operation. So every operating system has at least two modes. These are termed as dual mode, and two types of mode are user mode and kernel mode, which can be set by mode bit. Now 0 is for kernel mode, 1 is for user mode. At system boot time, the hardware starts in kernel mode. As we all know, it starts in a special mode, kernel mode. Then after the booting is done, it will hand it over to the user mode. The OS is then loaded and starts user application in user mode. So what is the significance or what is the importance of dual mode? It helps in getting out from some errant errors. Okay, so like in normal execution, if user process executing is done, simple application program is carrying on, then at the time of system call it will switch on to the kernel mode. Here you can see that a kernel mode is happening or executing the system call, and after getting the result it will come back to the user mode. So this is user mode, this is kernel mode. So this is called transition from user to kernel mode. Now talking about timer, so we must ensure OS maintains control over CPU. If there is any error happening at the time of execution of process, there should be some timer, okay, which should keep track of the process which is going on or executing. If there is an error, it should be decremented by 1, then 1, then 1, and after that when the timer stops, it should come out of the program. So this is called timer operations. Now process management. A process does nothing unless its instructions are executed by CPU. A process needs certain resources including CPU time. So we know process needs some CPU time, memory, input output devices attention, and during creation or during run time it is provided by these type of resources. Now as we know, the program is passive entity. It is not a direct execution entity, but process is active entity. At the time of execution, process is executing exactly, not program is executing. So program consists of different type of processes. Now for example, in a program we can see that there are printf and scanf type of statements. These printf statements are process, and that whole program can be termed as program. Execution of these processes are sequential. So sequentially it will be executed first, then second, then third, then fourth. Process is the unit of work in a system. Such a system is collection of processes, some of which are OS processes and the rest of which are user processes. Now talking about process management. So by multiplexing, they can be run concurrently. So the main thing is we have to concurrently execute different processes. OS is responsible for following activities. What are the activities which process can do for operating system? So firstly, creating and deleting both user and system processes, suspending and resuming processes, providing mechanism for synchronization, for communication or deadlock handling. So these are the things which OS has to do for process management. Now talking about memory management, so it also have to provide memories to the processes. So as we know, main memory is a repository of quickly accessible data shared by the CPU and input output devices. So central processor needs instruction from main memory during instruction fetch cycle. So it will take instruction from the main memory only, and both reads and writes data from main memory during fetch data cycle. So in von Neumann architecture, I'd shown you that it will take or fetch the data, and then main memory is large storage device. So it is usually large where we store our things. When program terminates, its memory space is declared available. So after the execution of full program, it will free up the memory and give to the next processes. Now talking about storage management. So in storage management, there is file system management and mass storage management. In file system management, it can create and delete files or directories and support primitives for manipulating files and directories. Now it can also map files into secondary storage, backing up files on stable. So these are common jargons which you can understand on your own. OS does following activities regarding mass management. So first thing is free space management. After that, it can also do storage allocation and also disk allocation. So these are MSMs. Now we have to talk about caching. So what is cache? It is just similar in OS like there in computer networking. As there was web caching in computer networking, here we will talk about operating system caching. It is an important principle of computer system. Information is normally kept in some storage system. Okay, it will be present in some storage system. If it is not, if a program or process needs to access some data, firstly it will check that whether it is present in cache or not. If it is present, then no problem, it will access from the cache. If it is not present in cache, then cache will mock up the process or program who is demanding for the data. It will fetch the memory or data from the main memory and give it to the program who is demanding for the data, and it stores one copy in itself also. Okay, so this is the process in which cache can execute. In addition, internal program registers such as index registers provide a high speed for cache. So what are the advantages of cache? So it is high speed, okay, and less traffic. So this is the advantage of cache. Without cache, CPU has to wait several cycles when an instruction was fetched from main memory. Now as you can see that if a program is demanding some A data, then it has to come first from magnetic disk, tertiary to or secondary to primary, then primary to cache. Okay, after cache it will go to the hardware register or processor. Okay, so this is the process in which migration of integer A from disk to register. Now there is a process called cache coherence. Okay, so in single type of processors where one program or one process is executing at one time, there is no error happening in this concept, in caching concept. But if there are different processors, then it can cause some errant errors. Okay, so what are those errors? If one copy is changed at one processor, then it should be reflected in other copies too. If it is not so, it will cause some errors. Okay, so for removing those errors, we have to implement cache coherency concept. In this, as soon as one processor changes the copy of the data in one processor, then it will be changed in all of the copies in every cache. So this is called cache coherence. So definition is that a copy of A must exist in several caches, and we have to make ensure that updates are made to each cache. Okay, in each cache changes has to be made. Situation becomes even worse in distributed system. So as I talked about multiprocessor system, it can also become worse in distributed system where several copies have to be handled. So in next video, I will talk about output systems, and the slides will be present in last video of this module. Till then, thank you.